Dear students, welcome to this MOOC on quantum chemistry for postgraduate students. MOOC, as you all know, stands for Massive Open Online Course. These MOOCs are basically highly multimedia enriched online courses which offer a unique advantage to the students to learn these courses as per their convenience at any time. The present MOOC on quantum chemistry basically deals with the application of quantum mechanics to the problems of chemistry. Quantum mechanics, as you all know, is a theoretical science of microscopic matter. Why we need a separate science for microscopic matter? The answer is because for microscopic matter, the dual behavior, that means the particle and the wave nature, become very important. So, quantum mechanics basically is the science which considers this dual behavior of microscopic matter. The fundamental equation of quantum mechanics is the Schrödinger equation, which you have already studied earlier. In this equation, which is represented as h cap psi is equal to E psi, h cap stands for Hamiltonian, which is an energy operator. Psi is the wave function or the state function of the system, and E is the total energy of the system. The entire quantum mechanics revolves around this time-independent Schrödinger equation. How to solve this Schrödinger equation? For this, one must understand how does quantum mechanics operate. The operation of quantum mechanics consists of 4 steps. First is, we write the Schrödinger equation for the system. Second is, after writing the Schrödinger equation, writing would mean here defining Hamiltonian explicitly. After writing the Schrödinger equation, we define the boundary conditions. That means the restrictions on the system. And third step is we solve the Schrödinger equation. The solution is something which is sometimes very difficult. And once we solve Schrödinger equation, out of the solution we get two things, psi, which is the wave function, and the total energy of the system. This psi, which is the state function of the system, is the storehouse of information. And the entire information about the system is contained in this psi. So these are the 4 steps by which quantum mechanics operate. And now in this course, we will first discuss the fundamentals of quantum mechanics. We will even mention how it originated from the failure of classical mechanics. Then, after understanding these fundamentals, we will solve Schrödinger equation for some systems. Some of them would be the model systems. For example, we will solve Schrödinger equation for particle in a box, then rigid rotator, then linear harmonic oscillator, and also finally hydrogen atom. These are the 4 systems for which exact solutions of Schrödinger equations are possible. And wherever possible in these solutions, we will compare the theoretical results which we get with the corresponding experimental results. After doing all this, the next step is to go to more complicated system. And we will discuss here the need of approximate methods. As you perhaps know, Schrödinger equation cannot be solved for any chemical system which contains more than one electron. And therefore, for the solution of Schrödinger equation, for such methods, we need approximate methods. We will discuss 2 approximate methods, basically perturbation theory and variation method. And we'll discuss their small applications. After these approximate methods, we will move to the electronic structure of molecules. And we will employ variation method to solve the electronic structure of molecules. Here we will discuss the case of hydrogen molecule ion and hydrogen molecule, and we will see how molecular orbital theory gives us the solution of these two problems. We will also discuss about the valence bond treatment and its use in the electronic structure of molecules. Under electronic structure of molecules, at the end, we will make a comparison of these two important theories of chemical bonding. After going through the electronic structure of molecules, we shall move in the last section to the Huckel molecular orbital theory and its applications. Huckel molecular orbital theory, perhaps you know, is basically a theory which is very useful for determining the electronic structure of organic molecules which are conjugated. We will discuss the various assumptions of this theory. The main assumption is sigma pi separation, because in these systems only pi electrons are considered and sigma electrons are assumed to be frozen. So we will apply Huckel molecular orbital theory to some simple molecules such as ethylene and butadiene, and later on move to some complicated molecules including cyclobutadiene. And lastly, we will also discuss what are the possibilities of extending this Huckel molecular orbital theory. We will discuss what are its limitations and how it can be extended further. Dear students, this MOOC on quantum chemistry has been very well designed and planned. And I am sure that you shall enjoy going through this course and it shall be a great learning experience for you. I advise you that whatsoever content, assignments and activities are included in this course, you do them very sincerely. And you will see that you will become very, very confident in the field of quantum mechanics and quantum chemistry. I wish you all the best.